they wrote it down from the see. So
Once.
All right.
There
Let
we
me get
go.
your attention again. I think we're ready to go, and it looks like it's going to allow us to write.
are we recording for Peyton?
Yes, I just started.
Oh, perfect.
Okay. Now, going back to what I was talking about. When we use the polar coordinate system, we're going to have two numbers that represent a point, but one of the numbers is going to represent a distance. Can you put your bag down so that I see it? Okay. Now, can you put your phone on? Okay. Thank you. All right. So this is a distance and this is an angle. All right. And so if I'm going to graph in the polar coordinate system, if I'm going to do it by hand, this is what happens. We draw a ray that goes in what I will refer to as the 3 o'clock position. Okay? When we do this on a graphing calculator, when we're in polar mode and we have the graphing calculator do something, all it's going to do is it's going to say, this is the polar axis, the thing in black, but it's going to have the x and the y axis behind it. Okay? But so if we graph by hand, all we'll see is this. The end point of that ray is called the pole. All right? The ray is called the polar axis, and then the two numbers that represent this point in the plane are the way we're going to get them is this. We're going to connect the pole to the point. All right, now there's a distance there, and that distance is r. And then there's an angle that this makes with the polar axis. And if we're measuring in a counterclockwise direction, the theta will be positive. And so if I had this point, then it would be the r, which is this number that represents that length, and the theta that represents that angle. Okay? So now contrast that to if we're graphing a point in a plane. So we have a point here. It can have coordinates that are x and y. Every time you see the x and the y, we're going to refer to those as rectangular coordinates. The reason we're going to call them rectangular coordinates is that the way we got those numbers was we dropped a perpendicular from here like that and a perpendicular from here like that, and this number was x and that number was y, but it makes this little rectangle. All right, so in the coordinate system that we're used to, just regular x and y coordinates, a point is identified by two numbers. Each of the numbers represents a distance, and it's a distance from either the x-axis or the y-axis. I should say it's a directed distance because we can have negatives. When we have polar coordinates, one number is going to represent a distance, one number is going to represent an angle. All right, now let's go here for a minute, and we're going to talk about plotting points in the polar coordinate system. There's going to be two ways to do it. Now, let me just make one drawing here. Suppose I gave you the number 140 degrees. All right, then if you were going to draw this by hand, you would draw a ray going to the right here. You would make an angle that's 140 degrees, and then you'd come up here to what you saw as being 5 units, and you'd put the dot at that place, and then where this r theta is, you would write 5, 140. All right, now that is a way to plot a polar coordinate. All right, now if you are given a graphing grid, now this is the graphing grid that did not show up, so I'll need to put in the big grid that we had and resize it, so give me a second. Okay, what did that just do? Let me go back. Right. Pictures, all right. Graph, insert.
Keep resolution.
It's not going to change it.
All right, it's not going to change how big it is, unfortunately.
Yeah, I know.
Okay, and now what I'm going to have to do is every time I insert one of these today, I'm going to have to do this, and then I'll try to do something that fixes that by next time. It took me a fairly long time to figure out how in the world I was going to try to do this. I'm not good at this kind of thing. Okay, so. All right, now, if we're going to plot a point on this, you need to see the following things. All right, this point right here is the pole. This is the polar axis going out in that direction. Now, you will notice that there are other rays going out here, and they happen to be 15 degrees apart on the grids that you've got. Now, if you go on the internet and just look up polar grids, you can get polar grids that are 5 degrees apart, that are 10 degrees apart, that are 15, that are 30. I mean, there's not sort of a standard size, but what we have here is one that's a good one. Okay, so anyway, that means since all the way around is 360 degrees, and each one represents 15, there's going to be 24 of these rays going around, where we get them separated out. All right, now you'll notice on this one that every other one is named, and it's named in radian measure here. All right, I could not find one online when I was looking for it originally on the packet that you had those degrees in degree measure. Okay, are they out there? I'm sure there were. I just couldn't find one, and so I've got them here with radians. Now, when we talk about plotting the points in polar, we will sometimes measure the angle in degrees like that, and sometimes measure the angle in radians. As long as all we're doing is plotting the point, it won't matter. When we have to try to find the angle, it's easier to find it in degrees than it is to find it in radians, and it makes sense. Okay, so now what I want you to do here is let's see. I need to tell you one or two more things. All right. Do you see how we have these concentric circles there? All right. Suppose I wanted to plot the point 360 degrees. All right. Then remember this is 15. So 15, 30, 45, 60. We could get that 60 is what pi over 3 was. So I know I'm going to be on that ray. Now, when I drew that, I don't mean for you to draw a ray there. I was just trying to signify that ray. And then this is at 1 unit, 2 units, 3 units, and so we would just put a point right there. Now, initially, we would not have drawn this ray in. I just did that for emphasis, and we would write 3, 60. So when I asked you to plot a point with polar coordinates, then that's what it's going to be like. Now, remember when you graph just in rectangular coordinates, you in the first quadrant you got both of them are positive, second quadrant goes negative, positive, etc. All right, we can have combinations of positive and negative numbers for r's and thetas as well, and so what we need to do is learn what that means. Okay, so let me just erase here, and I'm going to put stuff up, and we're going to just graph on this one for about 5 or 6 points here. All right. And again, the first thing I need to do is just make sure that I believe you understand what's going on. So I want us to do 5, and then let's do 7 pi over 4. All right, would you plot that point? All you're going to do is on one of your graphing grids, you're going to put that point in the right place and identify its coordinates. Right, you should be done, and so look up for a second and then let's see what's going on. Here's 5 pi over 3, there's 11 pi over 6. This ray right here is the one that is 7 pi over 4. Now, we could get that just using some degree stuff. When you're straight down here, this is 270, and remember each one of these were 15, all right? And so 7 pi over 4, if you're thinking in just regular degrees, is 315 degrees. All right, and so right here, this would go 15 above 270, 30, 45, which is what that is above 270. So it's going to be here. Let me say something differently for a minute. Look right here for a minute and you'll see, all right, now that's where 90 degrees is with the pole. And then if I split that, that's where 45 degrees is. So you can see that anything that ends in that has a 4 on the bottom it's either going to be there, it's going to be at the right angles to that, which would be here. They're all the ones that don't have the numbers on them right there. And it's down here, and then it's coming across like that. Okay, now, because I did all that drawing in that color, I'm going to plot the point then. Once we know we're on this ray, we're just going to count out 1, 2, 3, 4, 5, and we're going to put the point there, and then we would identify it by writing 5 and then 7 pi over 4 like that. All right. Is there any question that it should be in that position? Okay. Now, I'm going to do an ask question here. I'm going to ask you something as opposed to just show you how to do something. What do you think you would do if you had something like 4 negative 120 degrees?
You go clockwise.
All right, we would go clockwise, is correct, okay? Everything just blinked there again. All right, and so if I start at this ray, and then I go clockwise 120, where would I be on this? What's the number? I think there's a number in the position. Where would 120 be? All right, it'd be here where 4 pi over 3 is. So we would be on this ray, and so now we're just going to count out 4. 1, 2, 3, 4. Put the point here, and we would write that as 4 and negative 120 degrees. Right. Any question about that?
So we just plot the point, we don't like draw a line?
We don't draw a line to it, okay? Now, as a matter of fact, I probably will count off if I see the line drawn. Sometimes I think you may be tempted to trace over the line just so you're sort of assuring yourself you're in the right place and then putting the point. But if it says plot the point, then I wouldn't put anything on the graph other than the point on a test day. Okay, because I might interpret that differently. Okay. Now, do you think it'd be possible to have an R that's negative?
No.
Because R represents a distance. Okay. But now Anna's been here before, and Anna's saying yes, it's possible. Okay. Now what we have to do is we have to give it a meaning. All right. So I want us to look at. I'm gonna give us a number, and then let's see what we mean by this. All right. I want us to graph negative 3 pi over 3. Okay. When we're graphing in polar, the angle dictates, which of the rays we go to. So we always do that part first. So if I come up here to pi over 3, that's this ray. So I'm just going to put a little arrow on that ray to indicate, okay, we're on that ray. Now, do you see that if I start here at the pole and I start moving on that ray in this direction, those are going to be positive numbers, right? All right. And so what we do is we go back on the opposite ray. So it'll be the one back in this direction, and we go back whatever that number is. In other words, if that's negative 3, we go 3 in the negative direction there. And so that point right there would be negative 3 pi over 3. So it's possible to interpret, it's possible to have a negative R value as well as have a positive R value. So you always go up and you do the theta, and then you go in the opposite direction to normal if you have a negative for the R. Okay? Would everybody graph this one? Would you graph negative 4, negative pi over 2?
Do you need to draw those little tops of the arrows?
No, I just did that so I could sort of give some kind of indication without drawing on the ray itself where we're supposed to be. But I was just doing that so that everybody would focus on the right thing. Okay, now what I'm going to assume that you did here was you came down in this direction, pi over 2 units, which would be where 3 pi over 2 is, and then you went on the opposite ray to this ray, so you're going on the ray that goes up this way, and you're going to go 4 units, so 1, 2, 3, 4, and you put the point in that position. So negative 4 minus pi over 2. Okay, now out of things I expect you to know now, it's really just this. The R can be positive or negative, the theta can be positive or negative. The theta can be measured in degrees or in radians. Okay, now I want to try to ask you about one more thing. If I just have an X and a Y axis right here, and I put a point in this position, once I choose a scale down here, whatever scale we're going to have up there, can that ordered pair be represented by more than one set of coordinates once you choose your unit? In other words, like if you say, okay, each of these little blocks is going to be a centimeter apart, both sides. Then when I come up here, if I measured it and I found that it was 3 centimeters this way and 4 centimeters this way, once I wrote that, that should be the only coordinates that point has, right? As long as we keep our scale the same. All right? Now, that's not true when you deal with polar. Okay? So now, let me ask you a question here. All right? I want you to put a point in that position. All right? So just on one of your grids, put a point in that position. All right? I want you to write as many different ordered pairs in polar for that as you can that you're comfortable are right. I bet you can get more than one. Let me say something to try to help in one sense. I think you're going to be more comfortable in degrees than in radians when you try to do this one thing. So, let's see, would everybody agree that was 430 degrees? 4 comma 30. All right, so let's write 4 comma 30 as one way to represent that point. But now, I want you to get some other ways to represent that point too. I'm going to bet you that some of you can come up with that.
Is there like a max number that there is?
I'll put it this way. You won't find all of them in 5 hours if you were to do it. You can actually have infinitely many for each ordered pair.
Oh.
Okay, but you can what I'm really going to get towards here is I want you to tell me a formula that would get them all so we don't have to write infinitely many. All right, and we're going to get that as sort of like a next thing. But if you'll just write like 4 to 6 ordered pairs that would fit that, then you get an idea of what we'll have to do. All right, Thomas, tell me some of your 8 up here.
Oh, well, 3 comma pi 6.
Okay, now I still want to get to this point. So that first number can't be a 3 because I would just be on this circle here.
4 comma pi 6.
All right.
Negative 4 comma 7 pi 6.
All right, keep going.
4 comma negative 11 pi 6. -4, comma, -5 pi 6.
And then I have all those in degrees.
Okay, all right. It's going to be easier to check them in degrees. All right, now, as you were calling them out, I actually believe they're all right. Okay, unless I misadded something, I think they're all right. All right, tell them to me in degrees now.
4, 30 degrees.
All right, so that's the one we had.
-4, 210 degrees. 4, -330 degrees. -4, -150 degrees.
Okay, now all of these are right. How many of you got at least those 4 right there?
Well, I got them in.
One way or another.
I got them in.
All right, got them in radians up here?
I
Some
know
of you
they
got it.
counted-
Okay.
I know they counted.
All right, now, I don't care whether you were in degrees or radians, but the idea that we can get more than one is common. Now, I want to make a few things for us to look at here. Let's work in degrees simply because it's easier to add the right degree measure than it is to add the right radian measure sometimes. All right? Could we ever have a coordinate for that point that either did not have 4 as the first coordinate or did not have -4? In other words, what I'm saying, it has to be one of those two. Everything that got called out had to be one of those two, right? Okay, so there's just basically going to be 2 choices for R. The number that represents how far it is out from the pole, or the opposite of that number. Okay, now, I want you to look at this one and this one. What's the difference in those 2 numbers?
360.
All right, the difference is 360, right? Okay, now, if I wanted to give another one, could I write 4, 390?
Oh.
Would that be in the same place?
Would be.
All right, because on 390, if I start here and I go all the way around, that's 360, and then I got 30 more, so that's where we were to start with, right? Okay, now, how about 4, and then what if I added 360 to this?
750.
All right, 750. Now, do you see that all of those would work like that? In other words, I could keep adding 360 and 360 and 360, or I could keep subtracting it. Okay? Now, I want to put a blank sheet of paper in here for a minute. So for this one, do you see we could say we could write 4, and then we could go 30 degrees plus, well, I tell you what, I've got that degree sign. I want to leave it off for a second. All right, 4, and I could go 30 plus 360 times n, and I'm going to throw a little parentheses around this, degrees. All right. Now, what I'm going to write out to the side here is where n is any excuse me, where n is any integer. Now, does that make sense to you? In other words, if you put a 0 in for n, what do you get?
30.
All right, and if you put a 1 in for n, you get,
90.
all right, 390. If you put a 2, you get
750.
720, and so on. If we put a -1, we get Thomas's -330, right? And then we can put -2, -3, and so on. All right? So this little set of notation stuff right here takes into account the fact that the way you get this is you just go around the circle one more time, right? Because going around the circle is adding 360. Okay? Now, I want to think about this same thing if we had been in radians, what would it have been? Okay? So, would the 4 still be a 4 if we're measuring in radians?
Yes.
All right, it would, okay? Now, what's 30? What was our 30 in radians? Because somebody called it out. All right, it was pi over 6, right? And so we'd have got pi over 6. Now, how many radians do you have to add to go all the way around the circle?
2 pi.
All right, 2 pi. All right, and so if I put a 2 pi and an n, do you see that this expression here, and say where n is any integer, would have the same effect as that expression? Everybody okay with that?
Yeah.
All right, now I'm going to put a little star beside this one for a minute. Not because it's more important than anything else, but just because I'm going to come back and call attention to it again. Okay, now let me back us up to this page again. Notice that what we were talking about there a second ago was these are the ones that had 4, and the others that Thomas told us always had -4. You know, there's 2 with -4 there, 2 with -4 here. Okay, now if I wanted to write one that's equivalent to this, get all those, I could go -4. Okay, now if I'm going to use -4, I still want to put the 30 into the thing somewhere. So eventually I want an expression that says 30 plus something. But it might be a little bit hard to see it if we just go with that to start with. Anybody with an idea? All right.
180.
All right. Okay.
That's 210.
All right. So let's see. So what Daniel's saying is we could start at the 30 and then add 180, because that would get us to the place that's on the other side of the circle, so we go in the other direction, right?
So 180 in.
Okay. All right. Now, well, let's see. Now, this just gets us to this the first time. Okay. All right. Let's see. Let me go back and let's check. All right. If we're at 30, so I'm going to start here. So we went 30, and we go another 180. That puts us right here on this one, right? So that means we're on this ray right here. Okay, now if I'm on this ray, when I go -4, it means instead of coming in this direction, go in that direction, and I get to the right place, right? So that adjusting at 180 to get started is good. Okay, now once we get that 180 the first time, what do we need to do to this quantity to keep going around one more time around the circle?
Would it just be 180 plus 360 n?
All right, plus 360 in here.
Oh.
All right, okay, now this looks a little bit weird. All right, so I want us to take this statement right here, and I'm sort of out of room to write there, so I'm going to write it down here, and we're going to make it look better, and then we'll refer to it later. All right, so I want to isolate the 30, so I want to go the -4, comma 30. All right, now on the rest of this, do you see that the rest of that's got a common factor of 180? All right, so I'm going to put a 180. Okay, now if I take out the 180, do you see I would get 1 plus 2n, like that? Does that make sense? All right, notice here's the 30, and then this had a common factor of 180, so it took the common factor out, and then to make it give me this back, I had to put a 1 in that place and a 2n in that place, because 180 times 1 is that 180, 180 times 2n is this one. Okay, now, I'm going to write it one more time, change just a little bit more, not much. All right, I'm going to write this as 30 degrees, all right, plus 2n plus 1 times 180. Okay, now do you see that that's all the same thing? I just switch this around. Usually when you have an expression like this, you put the variable first. Okay, now I want you to compare this last green one with this red one for a minute. When these two numbers are opposites, you still get the same angle that you write out here. So you still get the 30, but when you do it this way, you get this expression as the thing you have to add to it, but up here, you get this expression. And we still need that part about where n is any integer. Okay? Now, I'm going to grant that that looks a little bit weird.
Yeah.
Okay? But let's go back, and as weird as this looks, let's try to change it to what it would be for radians. Okay? So I'm going to extend down just a little bit. All right, so if I want to make this radians, the 30 degrees was pi over 6, right? All right, now let's still keep that 2n minus or 2n plus 1, but in radians, what's 180 degrees?
Pi.
All right, pi. Okay, so now what I'm saying is this would tell me all the ones that could begin in -4 if we were measuring the angle in radians. All right, now I'm going to put a star here. I want to go back up for a minute because I got to make one other symbol. We've got it right here. Do you remember we went back here and we said, okay, we could put the 30 as pi over 6, and then the 360 would be 2 pi n, like that. Okay, now I want you to look with me at the next slide right here, finding all the polar coordinates of a point. It said, let the point P have polar coordinates r theta. Any other polar coordinate of P must be of the form r theta plus 2 pi n, or negative r theta plus 2n plus 1 pi. Okay, now I want you to see where that, the reason I was doing all this, do you see that this is the theta? So this is r theta plus 2 pi n. And then the one that was down there in blue at the bottom, all right, right here, all right, this is negative of r, and then it's theta plus 2n plus 1 times pi. Okay, so it's what they've got on that page. And all I try to do is get us to develop it for ourselves. Okay, now, if you take a trig class that lasts like a semester, because in some high schools and some colleges you do that, then you would go over writing expressions like this one and like this one until people were fairly good at it. Okay? But if I told you to write all of them, and you did not have some kind of way that you could write it as a formula, since there's infinitely many of them, do you see eventually you would die before you got them all written? Okay, and so if it's important for whatever reason to get an expression for all of them, then so you'd want to live and do some other stuff other than that one math problem the rest of your life, all right, then you want to understand something about that, right? In other words, mathematically, it's just good to know a way to write something that can represent infinitely many. Now, there's something about this that I happen to really like. If n is an integer, would the expression 2n represent an even integer or an odd integer, or sometimes even and sometimes odd?
Even.
Why even?
I mean, any number you stick in there is going to be even. Like if you put 7, it's 14. If you put like 2, it's 4.
Okay. In other words, if you double any integer, it always turns out to be an even integer, right? Okay. Now I want you to look at this one down here. If we have 2n plus 1, does that represent an even or an odd?
Odd.
Why an odd?
Because if 2n is always even and then you add 1, then that's going to just make it odd.
Yeah, if you add 1 to an even number, it makes it an odd number, right? Okay, now, if you're ever in a class where this kind of stuff is important, you have to remember that this is an expression that makes something even, and this is an expression that makes it odd, and that's what they've got in those two things. Okay, now, in one of the homework problems tonight, let's see, let me get back to our page here. In one or two of the homework problems tonight, it's going to say, write all the expressions for points that are equivalent to, and then it just gives you a point like we had there. And so you have to do what we did, but what they want you to do is instead of putting in 3 or 4 that have coordinates like 360 more or 360 less. They want you to write an expression like this. Now, books tend to write expressions like this where you're measuring in radians. If we want it to be in degrees instead, what do we put in place of pi? 180. Okay? What do we put in place of 2 pi? All right, and that's the only thing that you have to think about if you want to write it in degrees. Okay? Now, there will be some problems not where you have to use this. Okay? Now, before we go to that one, let's see. I'll get this. There was something that came to my mind that I want to make sure I showed you, and I'll get it later instead of right now. Okay. Now, the second major deal of the day is we're going to need to convert expressions from having rectangular coordinates, x's and y's, to polar coordinates, and vice versa. All right? And there's 4 little equations here. All right? These 2 are the ones that we will use to convert polar equations to, I said equations instead of equations. Let me write. Convert polar coordinates. Used to convert polar coordinates to rectangular coordinates. Okay, now I'm going to write something below this to illustrate. What's going to happen is you're going to be given an r and a theta, and they're going to ask you to tell them as x and y. Okay, and if we're going to do that, we're going to use this. All right, now, I want to show you how they got these 2 equations, and I want us to practice doing that technique. And then I'm going to show you about these other 2 because we don't use this one. We use something else that's a little bit better than that, all right, when we go in the other direction. All right, now consider this for a second. If I have just an x and a y axis, and then I draw the polar axis right there, then if I pick a point up here, this point would have rectangular coordinates x, y, but it would also have polar coordinates r theta. Okay, so if the polar coordinates are r theta, it means the angle right here is theta, and it means the distance from the pole to the point is r. So that's how I know that's r theta. All right, the way I know it's x, y is to get to that, I go over x and up y. Okay, now in this figure, because this is a right angle, I want you to concentrate on this for a second. If something's given to us in polar, we'll know r and theta. And what we're going to need to get is we're going to need to get x and need to get y. So if I know r and theta and I want to get x, I'm going to circle it. Then do you see that what we've got here is theta, and then we got an adjacent and a hypotenuse. So we can say the cosine of theta is equal to x over r. And then I'm going to put a 1 here and just cross multiply, and I get x equals r cosine theta. All right, and that's what that equation is. Now, you will remember that this is like the 3rd time, I think, that we've gotten x equals r cosine theta, because remember when we were dealing with vectors, when we changed it to a component form, the r is in the position where the length of the vector was. And remember, we had the length of the vector times the cosine of theta as the x coordinate. And then we had the length of the vector times the sine of theta as the y coordinate. And that's what we're going to get right here. Okay? So, now on getting that y one, remember, if we want to get this and we know r and theta, then the thing to do is use sine. And so sine of theta is equal to y over r. And if I cross multiply, I just get y equals r sine theta. So that tells me those two equations are true. Now, what I want us to do is I want us to start with that, and I want us to convert some ordered pairs from polar to rectangular. So would you convert this one? Just apply the formula. All right, if you have your unit circle, you'll want to keep a unit circle handy when you do all this work. All right, and the reason for that is when you see the theta that's given right here, if it's a number that's on the unit circle, then you're going to be expected to use the value off of the unit circle for the cosine and the sine. All right, if it's not a number that's on the unit circle, you're going to be expected to use your calculator to answer the problem, and we'll do one of those in a minute. This one's on the unit circle. Okay, now, what's the cosine at 7 pi over 6? Just either remember it on the unit circle. How many of you have a unit circle somewhere, unless you've thrown them away?
Is
All right,
it
just
negative
take it
1/2?
out.
Negative 1/2.
No, it's the
Negative root 3 over 2.
All right, it's negative root 3 over 2.
I was
Okay, now what
It's
cancels
so
here?
gonna-
What cancels?
twos.
The 2's, and so the x is negative square root of 3. Okay, now with the y's here, this will be 2, and then what's the sign at negative 7 pi over 6?
Negative 1.
All right, negative 1/2, and the 2's will cancel again. I'll get negative 1. Okay, so in polar coordinates, if we have this 2, 7 pi over 6, then that will be at the same place that negative square root of 3, negative 1 would be the y coordinate. Now, let me go back to the place I had this thing sized up in here for a minute. All right. Our original point was 2 and cosine of 7 pi over 6, right?
2, 7.
2 7 pi over 6. All right, so here's 7 pi over 6, and then the 2 would come to here. So this is where that point goes. All right, now, it's hard for me to draw something straight, so bear with me for a second. If I draw an x-axis right there, a y-axis right there, just superimposing it over our polar grid, all right? And then every place that one of those circles hits, that's 1, 2, 3, 4, etc. So out here, that's negative 1, negative 2. And then down here, this is negative 1. And right here, this is negative 2. Okay? Now, this ordered pair just turned out to be in x's and y's, negative square root of 3, negative 1. I just want you to use the eye test to see if that could be right. Do you see that that red dot's even with where that marker is right there? So that y is negative 1. Now, this red dot is slightly to the right of where this point is here. Okay? And the negative square root of 3 would be slightly to the right of negative 2. And so what it's just telling me is if I superimposed an x and a y axis over the polar grid, then these would be the coordinates I would get in x's and y's for that one that was 2, 7 pi over 3. Okay? Now, this is considered to be a good skill to know how to do, and so we're gonna do it about 3 or 4 more times because of the different situations that happen. All right, now I'm not going to graph any more of them. I'm just going to have us do the work. All right, so right here. All right, I want us to do this one. I want you to go 4, and I want you to go, excuse me, 225 degrees. All right, is 225 degrees on the unit circle? All right, it is. So now we're just going to fill in. So we're going 4 cosine 225. All right, and then we're going y equals 4 sine of 225. Okay, now this one turns out to be a little bit easier. All right, what's the cosine at 225?
Negative root 2 over 2.
Okay, so now this 2 on the bottom will cancel that 4 to be a 2. So this is negative 2 root 2. All right, now when we come over here and do this one, the sign turned out to be the same thing, right? And so we're just going to do the same work and get this. So our ordered pair turns out to be that quantity. All right, let me ask if anybody's making an association here. Are any of you thinking, all right, that 225 is in the third quadrant, so I bet both the signs are negative? Anybody making that association? Okay, as long as the R value is positive, that's a good association. If the R value is negative, it's going to be 180 degrees away from that, right? Okay, now, again, I need to give you a few more that are like this so you'll know what to do. All right, so if I gave you 8 and pi over 5. All right, it's pi over 5 on the unit circle.
No.
All right, no. All right, that makes this a calculator problem. Now, every time that something's a calculator problem, we're just basically filling in a form. This is 8 cosine pi over 5. And then for the y, it's going to be 8 sine of pi over 5. All right, now take your calculator out as opposed to expecting somebody else to do this one and you just copy down an answer in a second. There are a couple little things that we have to establish. All right, let me go to mode here, make sure. All right, I want to go back to function mode. All right, now, do I need to be in radian or degree here?
Radian.
All right, radians because there's no degree sign. All right, now, so just on a blank screen, let's see, second quit on it. All right, on a blank screen, we're just going to type that 8 cosine and then second pi. It helps if you hit the pi key. Back up, second pi. Do it again. Pi divided by 2. All right, no, divided by 5.
It's one of those days.
All right, you ever think you're losing it? You know, I mean, I'm making
Yes.
many more mistakes than normal, and that bothers me. All right. Now, look what happens. Press enter. All right. Remember, this is a decimal answer. We write decimal answers to 3 decimal places. Okay. So we're going to write this answer as an ordered pair at the end. Okay. So you always in front. So we're gonna be writing here 6.472. Okay. Now, to get this second one, we can just start typing again, or I like to do this thing. I like to go second enter and get that back up, and then just toggle over to where the cosine is and make it a sine. And that way I don't have to worry about, how much trouble I was having putting in the pi's and all that stuff. I don't have to mess with that. So now this will be 4.702. And that would be the answer to that problem. Okay? Now, let me put that down for a second. All right, let's do this problem. Suppose we had negative 14 square root of 2 and then negative 35 degrees. All right? Would you do this one? Because again, you don't know negative 35 degrees from the unit circle, so it's a calculator problem. What adjustments do you need to think about?
Mode.
All right, the mode adjustment, so what mode should we be in?
Degree.
All right, degree, because we see a degree sign. All right, so we're going to go to mode and change radian to degree. All right, and then we're just going to start typing in the stuff. Okay, now, remember that was negative 14 square root of 2. All right. All right, so I'm just going to go negative 14 square root of 2, and then cosine of negative 35. And press enter, and we'll get the answer. By the way, I changed mine to a classic print because of something I had to write out. So yours, when you got that square root, you just put the 200, right? I think, okay. All right, mine's in classic print. I'll change it back here in just a second. So anyway, that x coordinate is negative 16.218. All right, so. All right.
Yeah, it's okay.
All right.
Oh, no, it didn't. I didn't.
All right. Yeah, if it's not in degree,
Well, I thought I
Go
pressed
say
it,
what?
but I guess I didn't.
okay. Now, I want to ask you a question before we do the next one. Look at this thing. Remember, it was negative 14 square root of 2, and then the angle was negative 35. What quadrant's the point in?
Second.
All right, it's in the second, okay? All right, because right here, if I go down here, negative 35 degrees, but then it's opposite, I'm going up here. So we're in the second quadrant. Now, so we ought to get a negative on the first one and a positive on the second. Now, we got the negative here. The next thing should be positive. Okay, so now let's go second, enter, and then go back and change the cosine to a sine. All right, and it should turn out to be positive, so 11.356. Okay, now, is there any question about doing any of that? It's real simple. You use the calculator. We use those two equations, no other, so it's nice and easy to do. You would be surprised how often that's missed on a test, not because it's hard.
Because of the mode.
No, well, partially because of the mode. That's one of the big ones. But then, remember we've done other things that were sort of similar to this, and we got one more that's similar to do. Sometimes people just get the things confused with each other and miss it because of that. But I think you can tell if you're paying attention at all. This is not hard. This is so much easier than what we've been doing. Okay, now, let's go here. Converting ordered pairs from rectangular to polar. Now, before we do this problem, I need for us to go back to this page for a minute. And what I'm going to do is I'm going to insert a page because I can do that quicker than I can rewrite all of that. So right here, remember what we started with was we had a point up here, and this was R, this was theta, this was X, this was Y. That's the right angle. And then this is the point we're talking about that has the coordinates. So if these were given as X's and Y's, and I had to convert them to R's and thetas. So you got to remember, in the beginning, you know an X and a Y. All right, first of all, if you look at X and Y and R, because I've got to relate these two to R, do you see all that's going to be is Pythagorean theorem? All right, now, when you write the Pythagorean theorem, I want you to write the R squared on the left and then X squared plus Y squared. It just works easier that way. You're always solving for R. And so you might as well get it over there on the left by itself. Okay, so this is the equation that was that third equation over. All right, so I'm going to put a little box around that. All right, this one is important. Okay, now, the equation that connects the theta with the X and the Y is the thing that they had, which is the tangent of theta is equal to y over x. Now, that's not the one I want you to memorize for this, though, because most of the time the angle is not going to be something that's on the unit circle, and we're going to have to use the calculator to get it. And so remember, if you're looking for theta instead of for the tangent of theta, you got to do tangent inverse. So I'm going to write this. Theta equals tangent inverse of y over x. Okay, now to the right of that, I want you to put a comma, and I'm going to write if x is greater than 0. And I'll explain why in just a minute. But just write it, all right? And then I want you to write theta equals tangent inverse of y over x plus 180 degrees, comma, if x is less than 0. Okay? Now, in order to explain what the heck is going on there, remember when we were on the unit circle and we did tangent inverse? Remember we said on the unit circle you always got answer for tangent inverse between negative pi over 2 and pi over 2? Well, in degrees, that would be negative 90 and 90. So this is what that means. If I put one of these problems in on the calculator, it's always going to give me an answer between negative 90 and 90. Now, as long as the point that we're dealing with is in the first quadrant or the fourth quadrant, that's okay. Because if I'm in the first quadrant, the theta should be a number that's positive and less than 90. And if I'm down here in this quadrant, it's okay to measure the angle coming down like this and just declare it to be negative. So that part's okay. All right, now, in the first quadrant and the fourth quadrant, do you see that in both of those, the x coordinates are positive? Okay, so that's why I put over here, if the x is positive, this is all you have to do. So the way you recognize what quadrant you're in, just real quick, it's the number on the bottom. All right, if that number is positive, you just have to type that much in, hit enter, the calculator does the rest. Okay, now, suppose that I have something over here in the second quadrant. Since that can only return a number between negative 90 and 90, what we've got to depend on is this. That the way we're going to get that is we're going to have to add the 180 to it. Remember that other way of naming it? If it was r theta, it's going to be negative r and then adding the 180. All right? And so this thing about adding 180, you do that if this is negative. Okay? Now, every year when I talk about this, I don't think anybody's super comfortable about it till they do it. But we're going to do enough of this that we can get it. So those two equations, or those two things that are boxed in, this equation and those two equations, all right, that you need to be looking at as we do the work. Okay? All right. Now, right here. All right? Here, let's do a problem before we do the one that they've got. So I want to say convert the ordered pair -2 square root of 3. Wait, let me make that a plus. -2 plus 2 square root of 3 to rectangular coordinates. Wait a minute, I just wrote that wrong. These are rectangular, convert them to polar coordinates. Okay, now, thought process, this is an x, this is a y, so I need to get what r is. So if I go r squared, then I'm going to get -2 squared plus 2 square root of 3 squared. All right, so r squared will be 4 plus. Does everybody see that when you square this, you get 4 times 3? Because you square the 2 and you square the square root of 3. All right, so r squared is 16. So r is plus or minus 4. Now, what this means is we have two options that we can proceed with. All right, the first option you always want to use is the one where the R is positive, because that's the one that the theta is geared to go with. Okay, so you pick the positive one of these two numbers. All right, so now to get theta, we're going to go theta equals the tangent inverse of, and the y number goes on top, and the x number goes on the bottom. Okay, now my advice to you is don't try to simplify. In other words, don't try to cancel the twos or bring the negative up to the top. Okay, is this the kind where you add 180 or don't add 180?
Do.
All right, we do, okay? Because the x is the number on the bottom, and if you see a minus sign, you have to add a 180. Okay, now, the rest of this becomes a calculator problem, all right? Now, the good news about this calculator problem is it's not hard to process. All right, so let me hit clear here so all that mess is gone. So we're going to go second tangent, all right, and we're going 2 square root of 3. All right, now again, because I'm in that mode, I switched that so I could write something a few days ago. Let's see. I can get away with that parentheses. All right, so right here, let me go divided by -2. Now make that parentheses. And then go plus 180. All right, and check the mode that you're in degree mode. All right, press enter, and notice it gives us 120. Okay? Now, what that meant was this. When we did this, we were going to get -60 degrees and then add 180, and that got the 120. All right, now, some of you are going to be good at something right here, and some of you are not, so I'm just going to point it out for the people that catch on quickly. Right here, if we cancel this, this becomes negative square root of 3. And so the arc where the tangent's negative square root of 3 is down where -60 degrees is, because we need to get it in degrees, and then we just add the 180. But it's faster if you just do it on the calculator. Okay, now, let me put this down just quick enough to, or long enough to give us an answer here. All right, so the y coordinate, the theta coordinate that goes with this is 120. So this ordered pair in polar is at the same place that this is in rectangular. Now, generally speaking, you can get 4 values down here where the theta is a number between 0 and 360. Okay? Now, in the next problem we're going to do out of the book, it's going to say find 2 of them. All right, now let me show you one other thing here. If I want to get a second ordered pair here, then I want to use the negative down here. All right, but if I use that negative, remember when we were talking about plotting the points, how much different from this number does this one need to be?
360.
All right, now what is it? All right, it's going to be a 180 because this one's negative and that one's positive. So we can add a 180 to that,
Got it.
okay, and make it a 300. We also could have subtracted a 180 and made it a -60, okay? But we can get 2 sets of coordinates there real easy, okay? Now, with that thought, I want you to do that problem right there. Hurry back.
1, -1.
All right. want to be able to get another thing in before the bell rings if we can, just to sort of catch up with first period. Look at this for a minute. All right. We get the R is plus or minus the square root of 2. We want to use the equation solving for theta with the positive R value every single time. All right. So right here, when we go y over x, this time the x is positive. So do I need to add the 180? All right. No. So now this is just something you do with your calculator. And
make some updated announcements about athletics, and I'm sorry some things have been changed that I cannot get into Kansas right now. So if you'll listen up, I'll just go down the list of everything that we have as of right now.
add
McClure
180.
conditioning is canceled. McClure conditioning has been canceled for today. The Guy Gymnasium is closed for this afternoon. The Guy Gymnasium is closed. Softball players will need to contact their coach for additional information about practice. Baseball, JV baseball, you will list only no field practice. Varsity baseball, you have showcased. Golf, there is no practice. JV lacrosse, your game has been postponed, and practice is from 3:30 to 5 in the stadium field. Varsity lacrosse, you will practice in the stadium field from 3:30 to 5. Tennis is canceled. Soccer will practice in the stadium at 4:15. Again, softball, you need to contact your coach about where you will practice.
I'm just waiting.
Tennis, there is no practice, and track is as scheduled. There will be practice. The varsity lacrosse and softball
It never
games
rains on the
like
track field, huh?
tomorrow and Saturday have been canceled. Thank you.
Our coach isn't here this week. Our coach is on the Carolina Panthers.
But what was that
so
last announcement?
We're kind of just up to the assistant coach who's new this year, so he has no idea what to do.
Ooh.
What was the
So-
very last announcement?
But I know your coach is Coach Rob, then, right?
Yeah.
And I know Rob would say to you guys, hey, you owe it to yourself, you owe it to your school, you owe it to
Well, no,
your
usually
yard.
we just move inside, but
Oh, okay.
we're outside still.
Yeah. So he'd just have you run the halls. I know he's
Yeah,
done that
yeah, yeah.
before.
Yeah, that's true. Well, no, it's still.
Okay.
Comments?
Now, let me ask a quick question. I want to get to one more, but we won't have time. Does everybody understand the part about the theta here?
Yeah.
Okay? And you always want to use the equation for theta with the positive R value. Okay? And then, once you've got this one, you use the negative R value with the number that's 180 different from that. And you can either add it to it or subtract
So it
it
doesn't
from
matter
it.
which one you choose.
No, it doesn't.
Alright, awesome.
Wait, I might have missed it, but why don't you wanna do the negative one first?
Okay, if you do that, when I was designing to get this thing up, we were using the R as if it were positive, and therefore this formula is working as if the R is positive because the R was that length in the first quadrant.
I can say that.
Yes, you can. Go ahead.
She's teaching class.
Okay. Now. Does anybody know how to turn off the recording?
Oh, yeah, earlier I said press the button at the bottom. So,
Okay.
are you recording through QuickTime?
I assure yes,
No.
and I hope it was recording because it
Yeah, it said it was.
Go all the
You
way,
click
go
it and
to-
it said
Oh,
Yeah,
yeah,
it's the
yeah.
top
Yeah.
bar.
What?
full screen.
It's up
Go
on
to
the
the top bar next to the Google Drive triangle, that's where it's recording.
Right
Oh.
here.
No,
no, it's not.